Hey! Here's the part 2 of our pressure measuring instruments. Again, I am Engineer Jewel Ryan Nicole Birriosa, and I'm here today to discuss more examples of pressure measuring instruments. So let's go! Let's start now! I am showing you now the images or the pictures of the pressure measuring instruments that were discussed last time, and also the pressure measuring instruments that will be mentioned today. Again, we have the same sequence. First, introduction. I will be reiterating another introduction, or I will be mentioning almost the same introduction like in the first part, and then we have the example, another set of 5 examples, and then the definition, brief description of our specific instrument, the principle of operation, how does it work, and then its features, and then at the end of the day, realizing the importance of these instruments. As an introduction, I will be first discussing the definition of pressure measuring instruments. So, the pressure measuring instruments are the instruments used to measure and display pressure. So, they are also called or termed as pressure meters, pressure gauges, or vacuum gauges. So we have pressure measuring instruments, or we will be discussing more example of pressure measuring instruments here. But then I will be reminding you now what is the definition of pressure. Pressure in mathematics or in physics is defined as force over area. Or simpler definition is it is defined as the physical force exerted on an object. Usually, the force applied is perpendicular to the surface of objects. And then, of course, again, this is per unit area. The standard unit for pressure is Pascal, which is Newton, a unit of force, and then per square meter, which is a unit of area. So Pascal is Newton, also known as Newton per square meter. We have here the potentiometric transducers. Again, for the first pressure measuring instrument in our part 2 is the potentiometric transducers. Here we will be having the brief description. A potentiometric transducer is a mechanically driven variable resistor. Resistive transducers, or we also term this as potentiometric transducers, have many and varied applications in the transduction of measurements. This can be displacements, mechanical strain, pressure, force and load, temperature, and fluid velocity into electrical outputs. For the principle of operation of our potentiometric transducers, the transduction mechanisms are based on the change in resistance brought about by the measured. It consists of a wire-wound fixed resistor and a wiper arm that slides over it, and in so doing taps a different segment of the resistor. The displacement to be measured is linked by a shaft to the wiper arm, and a measure of the displacement is the fractional resistance or the fractional voltage. This is, again, the transduction mechanism. Next, the features of our potentiometric transducers. The resolution that one can achieve with this transducer depends on the gauge of the nickel alloy or platinum wire used. For extremely fine resolution, the wire is replaced by a metallized ceramic or a film resistor. If the resistance wire is wound on a donut-shaped tube, the wiper will measure angular displacements. Next, we have piezoelectric transducers. So first we have potentiometric transducers. Now we have piezoelectric transducers. Brief description: a transducer can be anything which converts one form of energy to another. Piezoelectric material is only one or is one kind of transducers. So we have many kinds of transducers. And we mentioned one earlier, the potentiometric. These materials undergoes squeezing and applying of forces or pressure to be able to convert it into electrical voltage. And then this voltage is function of force or pressure applied to it. The material which behaves in such a way is also known as piezoelectric sensor. Principle of operation. Piezoelectric transducer is based on principle of piezoelectric effect. This states that when mechanical stress or forces are applied on quartz crystal, it produces electrical charges on quartz crystal surface. And then the rate of charge produced will be proportional to rate of change of mechanical stress applied on it. Higher will be stress, higher will be voltage. Again, the higher the stress, the higher the voltage. Features: if same structure is placed into an electric field with direction of field reversed, the deformation will be opposite. One of the unique characteristics of piezoelectric effect is that it is reversible, meaning when voltage is applied to them, they tend to change dimension along certain plane. Yes, we have here the pressure relief valve. I think this is the most famous pressure measure, one of the most famous or recognized of engineers, the pressure relief valve. Description: the terms safety valve and relief valve are generic terms to describe a variety of pressure relief devices. A wide range is available actually based on the application and required performance criteria. As you can see in the images here, they show the devastating results of a failed safety valve due to probably poor maintenance, or ones which have been incorrectly sized, incorrectly installed, or incorrectly maintained. Principle of operation. Pressure relief valve is a spring-loaded valve which is designed to open or to relieve excess pressure and to reclose and prevent the further flow of fluid after normal conditions have been restored. It is characterized by a rapid opening pop action or by opening in a manner generally proportional to the increase in pressure over the opening pressure. Features of our pressure relief valve. It is again a spring-loaded valve which is designed to open, to relieve excess pressure, and to reclose and prevent the further flow of fluid after normal conditions have been restored. Oh, we have second to the last, pressure vacuum valve. Brief description: pressure vacuum valve or PV valve can relieve moderate changes in tank pressure due to variations in temperature and vapor quantity. A drop towards vacuum conditions as the result of the condensation of steam will also be handled by the valve. Rapid pressure rise due to an explosion would not be relieved. So let's discuss the principle of operation. Once the pressure or vacuum in the tank reaches the pallet closing force, the pallet will start to lift off the seat and allow flow through the valve. Due to its air-cushioned sealing technology, one feature also of our valve, these valves prevent emission losses until very close to the set pressure, and then prevents air intake until very close to the set vacuum. Here we have the features. The PV valve and the ventilation system will prevent either over or under pressure. The vapor passes to atmosphere through a gas flame trap. Drop in tank pressure compared with that of the outside atmosphere will make the small valve open downwards to equalize internal pressure with that of the outside. Last example, the pressure gauges. Brief description. Bourdon tube pressure gauges are the most frequently used mechanical pressure measuring instrument. So, we also mentioned the Bourdon tube last time, right? Their pressure element is often referred to as a Bourdon tube. Again, I will be highlighting this. The pressure element is often referred to as a Bourdon tube. So, the pressure element of a Bourdon tube pressure gauge is a Bourdon tube. The French engineer, again, Eugene Bourdon, made use of this functional principle in the middle of the 19th century. That's why it is called Bourdon tube, right? Because of, in honor of the great Eugene Bourdon. It is based on an elastic spring, a C-shaped bent tube with an oval cross section. Principle of operation. When the internal space of the Bourdon tube is pressurized, the cross-section is thus altered towards a circular shape. The hoop stresses that are created in this process increase the radius of the C-shaped tube. As a result, the end of the tube moves by around 2 or 3 millimeters. This deflection is a measure of the pressure. It is transferred to a movement which turns the linear deflection into a rotary movement, and via pointer makes this visible on a scale. So that's it for today. If you wish to have a copy of this PowerPoint presentation, and if you also have some questions regarding the topic, kindly email me at ryannicole05@gmail.com. Thank you.